Hi everyone, this is Sushant from Unity Devz. Welcome to our today's session, which is part 3, where we will understand how you can achieve parallelism or processing records parallelly by varying batch block size. And also we will understand about the max failed records configuration in batch processing. What will be the impact of that while processing any records in batch process. So guys, if you haven't watched part 1, please watch it because in that video we covered all the basic understanding required to proceed with the practical batch processing use cases in upcoming videos. So let's get started with the first topic, how you can achieve parallelism by varying batch block size. Okay. So guys, as you can see, I have created some use cases where I will show you how you can achieve that by varying batch block size. So batch block size is a configuration available at batch job component level. You can see. Okay. So as we discussed in part 1, so this field determines the block size, basically what the block size will be. Okay, so let's say batch block size is 1 and let's say you are getting 50 records from the input. So it means one record will be assigned to one block at a time. So there will be 50 blocks that are created. Okay. So to process those 50 blocks, we have, in my machine I have 16 threads. Okay, so one thread will execute one record from one block at a time. So parallelly 16 records will be processed. Okay, next time another 16 records will process parallelly, like that. So I will show you by performing one practical example. Okay, so as you can see in my transform message, I have 1 to 50 records having MIME type application as JSON, and in batch job component level I have configured this batch block size as 1. Okay, so let me debug my Anypoint Studio application. Okay, so guys, as you can see, application has been deployed, and in this use case, as you can see, I'm passing records from 1 to 50. Okay, so based on the batch job component configurations, I have configured batch block size as 1. It means one record will be allocated to one block, so there will be 50 blocks that are created. Okay, so because there are 50 blocks created, and I think in my computer, based on the number of cores, I have 12 threads. Okay, so one thread will execute one record from each block at a time. Okay, so one thread will execute each record from each block at a time. Okay, so in parallel 12 records will be processed parallelly, I can say. Okay, so to see this behavior, I can show you by hitting this flow how it works. So if we click on send, loading phase completed. So in console, as you can see, 12 records has been printed, 1 to 12, because I have 12 threads, so 12 records are processed parallelly, one record from each block. Another 12 has been printed now, then another 12, 25 to 36. Okay, another 12, 37 to 48, and then the remaining ones, because we have only two records left, 49 and 50. Okay, so guys, that's how it works. Okay, so to explain you in a more I can say elaborative way, let me draw one diagram in a paint. Okay, so guys, because we have 50 blocks, one record will be allocated to one block, so it means the first block will consist of record as 1. Okay, the first block is having record as 1. Okay, second block will be having record 2, third block will be having record 3, fourth will be having record 4, fifth will be having record 5, sixth having 6, up to 12 because I have 12 threads. Okay, so if I click here, 1, 2, 3, 4, 5, 6 and up to 12. Okay, so because I have 12 threads, so one thread will execute one record from each block at a time. So because one block is having only one record, so that block is completed in a single hit. So one thread will execute one record from each block. So because in first series we have 12 blocks having one record each block, so these 12 blocks will be executed parallelly as I showed you in the console. Those 12 are printed first, and then another 12 printed first, and then another, and so on. Okay, so this was our first use case, guys. I hope you understood it. Okay, so and in the incomplete phase, as you can see, all the 50 records are loaded previously, all are successful. Okay, all are processed. Okay, there is no failure. Okay, so moving on to the next use case, guys. So in that use case, we will try to increase this batch block size. Okay, so let's say this time this batch block size is 10. Okay, so what does it mean? 10 records will be allocated to one block. Okay, 10 records will be allocated to one block. It means there are 5 blocks this time. Okay, so how you can look at those 5 blocks? Like this. Okay, so these are the 5 blocks. In first block we have elements 1, 2, 3, 4, 5, 10. Okay, in next block we have elements 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. Similarly, guys, in third block we have elements from 21, 22, 23, 24 and so on till 30. In fourth block we have elements from 31, 32, 33 and so on till 40. Okay, and in the fifth block we have elements from 41, 42, 43 and so on till 50. Okay, so this is the structure that has been created based on the batch block size. Because batch block size is 10, so 10 records will be allocated to each block. So there are 5 blocks that has been created. Okay, so because I have 12 threads in my computer based on the number of cores, so one thread will execute one record from each block. So parallelly it should print 1, 11, 21, 31 and 41 first time. Next time it should print 2, 12, 22, 32 and 42. Third time it should print 3, 13, 23, 33 and 43, like that. So let's see, is that the same scenario there in the Anypoint Studio? Okay, we will see it by running this use case. So this time we have this batch block size as 10. Okay, and we will okay, deploy our application again. So guys, our application has been deployed. Okay, we will hit this flow and see the behavior. So I send the request, loading phase completed. So guys, same thing, 1, 11, 21, 31, 41. Okay, next time 2, 12, 22, 32, 42. Okay, 2, 12, 22, 32 and 42 parallelly. Third time 3, 13, 23, 33 and 43. Okay, so one thread is executing one record from each block at a time. Okay, and fourth time 4, 14, 24, 34, 44. And last time the another one is 5, 15, 25, 35, 45. 5, 15, 25, 35, 45. Similarly, it will process the remaining ones until it reaches the last 50. So because I have added the delay as 10 seconds just to show you how it works. If I remove this delay, it would have executed it very fastly. Okay. So finally all records are processed successfully. Okay. Now we will get the summary in the on-complete phase. How many records are processed, how many are failed, how many are loaded. Okay, so total records 50, failed records 0. Okay, successful are 50 and there is no failure. Okay, processed are 50. Okay. So guys, that's how this batch block size works. Okay, I hope you understood. And now I will show you by adding one more batch step. Okay, how it works in multiple batch steps. Okay, so guys, this is the use case I have created to understand how we can execute um, two batch steps by varying batch block size, how these two batch steps will work. Okay, so this time to understand this concept, I have passed records from 1 to 10 and batch block size I have given it as 10, sorry 3, let's say. Okay, so this time because batch block size is 3, so it means 3 records will be allocated to one block. So there will be how many blocks? 4 blocks. One block having 3 elements, another block is having 3 elements, and third one is having 3, and fourth one is having 1. Let me show you what I'm saying. Let me open a new file. So this time there will be 4 blocks. So first block is having a element 1, 2 and 3 because batch block size is 3. Another is having element 4, 5th and 6th. The third one is having element 7, 8 and 9. Okay, and the last one is having element 10. Okay, so this is the block structure we have. So because I have, based on the number of cores, I have 12 threads, so one thread will execute one record from each block at a time. So 1, 4, 7 and 10 will be printed first, and then 2, 5, 8 and then 3, 6, 9. Okay, so let me show you. You will get more clarity when I will do the run this use case. Okay, so let me run this use case and debug it. And also this time we have another batch step, so we will see how another batch step is working parallelly. So guys, the application has been deployed, so let me hit it from post 1. So loading phase completed, we got the response. If we go to the console, you can see 1, 4, 10 and 7 has been printed successfully, as we 1, 4, 7 and 10 parallelly has been printed. In another step, 2, 8, 5, 6. Okay, like that. Okay, so first it prints 1, 4, 7 and 10, like as we saw previously, and then it printed 2, 5, 8, 2, 5, 8. Okay, and then it printed 3, 6, 9, 3, 6, 9, where it is 3, 6 and 9. So after that it printed 10. Okay, why it printed 10? Because all the records has been processed, and this 10th, it was a different block, so it was passed to the next batch step. It was passed first, it was passed to the persistent queue, and from persistent queue batch step 2 picked it. Okay, because it was already processed. Okay, then the remaining 3 blocks. So firstly this block was processed, it was sent to the persistent queue, and the remaining blocks were processing. Okay, once the remaining blocks processed successfully, the another batch step picks this block from the queue, persistent queue, and processed it, and prints batch step 2 is 10, and then remaining records which are a part of block 1, 2 and 3. So again in same series it printed it 1, 4, 7, 2, 5, 8, 3, 6, 9. Let me show you. So 1, 4, 7, 2, 8, 5, 3, 9, 6. Okay, same elements. 3, 9, 6 is, so because it is asynchronous, that's why like the order doesn't matter. So 3, 6, 9, 2, 5, 8 and 1, 4, 7, like this. Okay, 1, 4, 7, 2, 8, 5 and 3, 9, 6. Okay, and in the last we got the summary of all the records. How many are processed, how many are filled, how many are loaded. And this batch instance, batch job instance ID basically determines a particular instance for which that batch job is running. Okay, if a particular user, let's say particular user hits this service, so that will be considered as a particular batch instance, and let's say another user again hits the service, that will be considered as another batch instance. So batch instance ID is basically to uniquely identify a particular process which has been triggered at a particular time frame, at a particular timestamp, you can say. Okay, so guys, I hope you understood this concept clearly. Okay, so guys, in next part we will cover max filled records and max concurrency concept in batch processing. Thanks for watching this session. See you soon guys. Bye.